Hi everyone, my name is Hanlie Jansen and I'm one of the Extension Officers here at Angus Australia based in Gundawindi, Queensland. It gives me great pleasure to welcome you all to Introducing Angus SteerSELECT webinar. Thank you for your attendance and your interest in Angus SteerSELECT. So just before we get into the webinar, I just have a few housekeeping points I need to make. We will be recording this webinar and it will be available on the Angus website for future reference. If any of your other colleagues are unable to attend, they'll be able to find it there in future. If you have any questions, please feel free to put them through under the Q&A function at the bottom of your Zoom page. I will be monitoring this throughout the webinar. And there will also be opportunities to ask your questions midway through the program as well as the end. We'll hopefully have this session wrapped up within the hour, so not asked to take up of everyone's day. And I'd like to take this opportunity now to introduce our presenters. So we've got Christian Duff, who will be taking us through. He's our Genetic Improvement General Manager here at Angus Australia, and he will take us through an overview of Angus SteerSELECT and cover the background of SteerSELECT as well as the product overview. We'll then have Dr. Juka Poneto, one of the research scientists from CSIRO, our collaborator in the development of Angus SteerSELECT. Juka will take us through a technical overview of the development and validation of Angus SteerSELECT, as well as a technical overview of breed check, which is a component of Angus SteerSELECT. After this, we'll have a brief pause for a Q&A session, which will be followed by Adam Allingham, our Member Services Manager, providing us with further details on the ordering of Angus SteerSELECT. To close the webinar, I will provide a quick guide on how to access our results and an overview of where you can find further resources about SteerSELECT before our final Q&A session. I'll now pass on over to Christian to do the introduction to SteerSELECT. Thank you, Christian.
Yeah, thanks, Hanlie. I'll just share my slides and we can get into it. So welcome everyone. Good to see everyone online and a lot of familiar names there. So I look forward to seeing that. I assume you can see those slides now, Hanlie.
It's all good, Christian. It's come through.
Thank you very much. So what I'm going to do is give you the real high-level overview of SteerSELECT. This has been a product we've had in development, and it's had quite a long gestation period in regards to development, but we wanted to make sure we worked out with our collaborators like CSIRO and really got the product right, did lots of validation, did lots of engagement in the field, so we understand the product really well and are really confident in it. And it really adds to our suite of genetic evaluation products we have at Angus Australia, which is the most important thing. So just to take you through these slides briefly, really need to acknowledge our collaborators in the development of this. So CSIRO is our main collaborator. They're the organisation we collaborated with to develop SteerSELECT and particularly the genetic predictions that come out of that. And Juka will take you through all the technical detail of that, or some of the technical detail. But without CSIRO, we couldn't do this. But we here at Angus Australia have the facilities. Once we get that good technical information through from the likes of CSIRO, we can build that into our systems and provide that out to industry, which is where we focus on. Definitely need to acknowledge our partners in the genotyping space and the delivery of these genetic product spaces, both Nige and Australasia and Zoetis. We are strong partners with both of those organisations, and they have been pivotal in helping us move forward with SteerSELECT and as well as our other genomic products. So importantly, they are helping us co-deliver this product to industry, and that's something we'll build on with those companies as well with our strong partnership. I've got a range of brand owners and feedlots listed there too: Rangers Valley, Tees, Stockyard, NH Foods and Elders Clara Feedlot. They're the organisations we did a lot of our validation and field work with. Rangers Valley should get a special mention because they are heavily involved in our reference population program and have been for over 15 years now. So it's been a really long-standing commitment for them to Angus Australia and the Angus breed in Australia. to help us collect all that really good carcass data and information that helps us develop tools like SteerSELECT, as I'll talk about in a second. So they're all really good collaborators, and they obviously have a fair skin in the game in the Angus genetic space because it affects the productivity and efficiencies they get in their feed yards and through to their brands to the consumer. As I've mentioned previously, SteerSELECT is really now an addition to our suite of evaluation products. What's something I'm really proud of here at Angus Australia is we've managed to really build our genetic evaluation products available to the industry. I've been at Angus Australia now just over 10 years, and when I first got here, we had our breed plan evaluation, Angus breed plan. That's still our gold standard pivotal product for our seed stock production. We shouldn't forget that, as we call taste these days. But we had now been able to build in additional genetic evaluation products to suit our suite of Angus producers, whether it's Angus influence like AngusSELECT and the Ultra Black and Brangus breeders we work with, whether it's our commercial tools for Angus breeders like HeiferSELECT, which has been in development and been in commercialisation since 2017, or SteerSELECT we've just brought online now. So the little graph I've got on that slide there shows you the growth in Angus HeiferSELECT, because this is really I guess the sister product of SteerSELECT. We started with those a genomic tool for Angus commercial heifers back in 2017, and you can see the growth there. Just to date, I updated these stats yesterday, we've undertaken just over 60,000 tests, and you can see the growth of that. We've still got a couple of months to go in 2024, but the growth is in those products and people using them, but obviously still the tip of the iceberg with the amount of commercial heifers out there. And now we look forward to seeing the uptake of SteerSELECT that we have available. Just as background and where we really get to, and this is really just putting a little bit of the technical stuff in very short terms that Juka might cover in more detail, is being able to develop these tools come down to having a few key aspects. So the first thing is we need a reference population of data. So we've got a recorded population of animals that have been phenotyped, hopefully for the traits relevant to commercial production, like carcass performance and feedlot performance and so on. And we also have information on those animals like genotypes, and we can compile that information together, put through our evaluation models, and give us predictions, as long as we've got obviously an appropriate genotype on those animals, like we have with Negen and Tweetus, those Angus-specific genotypes, to put through our predictions to give us our predictions out the other end. And those predictions are obviously underpinned by our work with CSIRO in this case. So without that reference population of data, we can't do anything, and that's one of the real strengths of Angus Australia, having that data, both animals that are phenotype and genotype. And we should acknowledge here that that's not just our reference population programs like the AngusSELECT benchmarking program you might know about, where we drive that from an organisation level, but also our member data that feeds into these products as well. So our members are really good at collecting data, and lots of genotyping going on too. So collectively, that information gives us a really powerful data set, both from more of a research level, but also a production level as well. Just looking a little bit more detail on SteerSELECT, and I apologise for a wordy slide here. What is SteerSELECT? So in a nutshell, it's a genomic selection tool to help identify the genetic merit of Angus steers and terminal heifers that are Angus animals, essentially. So it's not calibrated for crossbred Angus or anything like that, but it's best suited to those animals that are Angus, because that's what our reference population is, Angus animals in this case. You see there, we call it SteerSELECT, but you shouldn't also forget about it's actually applicable to any animal that goes into the supply chain, the beef supply chain. So you can think of it, if you've got a group of surplus heifers that are not being bred, it could be appropriate to those as well. What does Angus SteerSELECT provide? It provides 9 genetic predictions across the growth, feedlot, and carcass and resilience traits, and I'll talk about those in a second. We've got an overall selection index and some ratings around that index as well to really simplify the selection on that information. We also have Angus Breed Check, which is a genomic breed composition prediction, and sire verification where possible, if we know who the possible sires are and we have a genotype on those. So it provides a lot of information through to help selecting those steers and drafting and sorting those steers. Really provides that extra information on the genetics in those steers. Even if you know on a broad level through sires and sort of background breeding, this really helps us to get a bit more precise about it on an individual animal basis, and on a drafting basis, of course, about which supply chains they might be best suited to, whether it's a long fed or grass fed or short fed, etc. one of the first bit of information we give out of this product, and again, Juka will give us more technical detail on this, is Angus breed check. So it's been a bit of a topical one at the moment because of the discussion around breed content claims around Angus and other breeds. So I'm not going to get into that discussion today, but what we have now, we've had this for a while with our Angus SteerSELECT, is we have to actually have a DNA-based breed composition test called Angus breed check. Really focuses on the Angus content, but also allows us to predict the non-Angus component in broad breed groups as such. In regards to SteerSELECT, like EFA-Select, if an animal's 87.5% through this prediction, we give it the Angus tick. If it's below 87.5%, we will give genetic predictions on that animal, but we'll put some cautions around it. And as well as that, we also provide what breed content that other part might be in that animal other than Angus. If an animal is coming back as being 50% below 50% Angus content, then we actually don't give any genetic predictions, but we will give you the breed content predictions as such. So we sort of just put that in as a little bit of a quality check because our reference population is Angus animals, and that's what the predictions are best suited for. But as you know, standing alone, the genetic prediction for breed is useful selection information in itself, potentially depending on what your supply chain is. This is a little bit of an example. So when you get breed check results, we'll give you a broad, this is the Angus percentage and the non-Angus percentage. That's if it falls below that 87.5%. Like you can see that example there, this animal's 83% and 17% non-Angus. We also then break that up into those breed groups of British, Indicus, European, Dairy, and Wagyu. So we provide those percentages as well, just to give a bit more information about what that other background may be. And it shows us through the validation stage that information is useful to help predict maybe how the animals perform out the other end for some of their carcass traits, but also if they're going into branded products, that might be of interest as well, of course. In regards to the genetic predictions, as I mentioned at the start, we provide 9 genetic predictions. There's those traits listed there, from yielding weight, average daily gain, daily feed intake, carcass weight, Australia, rib fat, MSA marbling score, ossification, immune index, which is our resilience trait developed with CSIRO, Angus Steer value, which I'll talk about in a second, and Angus SteerSELECT stars, which is basically just a star system, 1 to 5 stars based on the Angus Steer value. So essentially, all these traits are interpreted the same. Underneath them, there is like an EBV or a genomic breeding value, like you see in the seed stock world, but essentially we convert it to an easy to read 0 to 100 score. We transform the scores. So, and a higher score means more of the trait genetically. That doesn't mean that's a good thing. So if you happen to get an animal that has a higher daily feed intake for efficiency, a higher score would mean more feed intake. That's not necessarily good, but really depends on what your selection program is, and we'll let the users determine what's good, bad, or indifferent, I guess. Another way to look at that is a score of around 50 is the average genetic merit of a modern Angus animal. So in the reference we use to convert to a 0 to 100 score, it's based on about 50,000 modern day Angus commercial animals. And that's a combination of Angus heifers and Angus steers as well. So 50 is about where the average Angus would be today. You probably could also argue it's probably a little bit at the top end of an average Angus because a lot of people that have been using these products and been testing with are pretty progressive producers that have got a lot of selection going on, whether that's obviously through their size selections, but other selection methods as well. So they're the traits, and obviously you can delve into it more, and Hanlie will tell you where to find more information on each of those in our resources guides. We also produce at this stage one index, so that's a combination, and we call it Angus Steer value. And essentially it's a combination of 20% on average daily gain, 25% on daily feed intake, but it's actually trying to reduce daily feed intake. So push the production, but make more efficient animals that eat a bit less to get there. Increase carcass weight, a little bit on eye muscle area, a lot on marbling, so 27.5% of the weighting on marbling, and a little bit on immune competence to try and hold that immune response as well. This is just an initial index, and I think it does rank animals well. The green graph there just shows you, I used about a population of about 2,500 modern day Angus animals and selected them on their Angus Steer values. And if we select the top third, this is where their traits would look relative to one another compared to the rest of the population they came from, the other 2,000 odd steers. So you can see there you'd end up with more yielding weight, more average daily gain, slightly less feed intake, much more carcass weight on muscle and marbling, and the other traits would say about where the population would be at this stage, because there's no direct weighting at this stage on ossification or rib fat, but there is a little bit on immune competence, and that improves a little bit, as you can see there. So it's quite a nifty little index we developed, but it's really a starting point, and we're obviously thinking about other indexes going forward as well, which we can talk about later on. This is an example of a steer, and this is an actual steer, and his SteerSELECT values. So you can see here that this is actually a really high ASV steer, 99, so top of the tree basically. And you can see where he sits for those traits like yielding weight, average daily gain, daily feed intake. He's one of those unusual ones that does break the curve. He's got higher ADG compared to average, but lower daily feed intake. And then you have a look at his carcass traits for carcass weight, muscle, eye muscle area, and obviously MSA marbling driving that as well. So you can see through his genetic profile why he'd be a high index steer as such, and that's what we can find with this tool. Just a bit more figures for you, and I do apologise a number of numbers on this slide, but essentially here what I've done is I've used a population of either long-fed steers, 3,300 of those, or short-fed steers, just under 500, and I've ranked them on one of their genetic predictions. So if we just focus on marbling, which is over in the first column, MSA marbling, we look at the long-feds. I ranked them on the MSA marbling genetic prediction. We then looked at the average genetic prediction and the average marbling score. So these animals are actual phenotypes measured, performance measurements, chiller measurements in this case. What the average was for the top 100, the middle 100, and the bottom 100 when we rank them that way. And you can see MSA marbling, when you looked at the genetic predictions, they averaged 90, 50, and 12. That's based off our predictions. But when we actually looked at their marbling scores, the top 100 averaged 763 in MSA marbling. If you're not familiar with MSA marbling, and you're more familiar with osmeat, that's about a 5.5 osmeat marble score, which is pretty high for an Angus in this sort of system. And then you can see the difference to the bottom there. It's really picking the differences up really well. I should preference this isn't a pure validation, because these are animals in our reference as well. It's more like just a testing procedure to make sure we went through it. And Juka will talk more about an independent validation, but this showed us that things are working really well. If you want to have a look at another thing, and probably to explain something like daily feed intake, you can see there, as I said, higher values will give you more. So when we rank them on daily feed intake, the highest group also ate the most. So they ate 18 kilograms per day compared to 11 kilograms per day, which is really significant when you think about it from an efficiency perspective. As long as you're not offsetting that with lower production as well, I guess, from a overall level. So that's just showed some really nice results, and those results here are replicated across those traits and across the production system, so the long fed and the short fed. So it shows it works definitely in both systems, whether we're short fed or long fed. Just another way to look at it, another way, particularly brand owners and processors and abattoirs like to think about is, what does it do to my compliance rate if I have something like marbling built into my requirements? So this is where we looked at compliance rate for MSA marbling. So I did exactly the same ranking as I talked about before on the same groups of animals, where we basically said, what's the compliance in those groups if, say, you wanted to at least get a minimum osmeat marble score 3 in the long fed and a minimum osmeat marble score 2 in the short feds. You can see there for the top 100, when we ranked on MSA marbling, 100% were compliant. They all meet marble score 3. Actually, they all met marble score 5. Okay, so it really is the animals up the top end there. When you look down the bottom 100 for long fed, only 8% met the marble score 3. So you can see the differences there in the predictions are picking up. Similarly to the short feds, for osmeat marble score 2 compliance, you can see 84%, 36%, and 8% collectively across those different subgroups within that population of animals, showing that you can also think about it from not just an average performance, but also a compliance perspective, depending on what the specs for a brand or a processor or a grid might be, which I think is pretty important. Now, the other thing we looked at here is for the same group of animals, the long-fed and short-fed group, we also just ranked them on the Angus SIRO value, so not the individual traits. We said, okay, to test out to see our index is working effectively. If we rank them on the Angus SIRO value, you got the long-fed guys, the top 100 steers, the middle 100, and the bottom 100, like the short-fed guys. And if you just look at the long-fed guys and compare the top 100 to the bottom 100, what it's showing is here, just ranking straight on that index, you get heavier carcasses by 53 kilograms. You get 258 difference in MSA marbling score, which is about 2.5 Osmeat marble score. You get more eye muscle area by 13 square centimeters. You actually get greater efficiency too because they eat less compared to the bottom guys, and you get slightly more ADG as well. So, I think we can all see if we had ownership of those top steers compared to the bottom steers, where that value might be. So, in genetics and genomic predictions allowing us to pick up those differences, which is really cool. So that's the end of my section, Hanlie. But as you can see, lots have gone into it, and there's a lot more to say. So, and I know time's a bit short today. We want to keep it within an hour, so I might just pull up there, and we can pass on to the next speaker, and I can stop sharing my slides, Hanlie.
Sounds good. Thank you very much, Christian. Thank you for providing a comprehensive view of the product and for those numbers to show the technical side. Just a reminder to everyone, please feel free to add any of your questions through the Q&A function. I'll keep monitoring those during Juka's presentation. I'll now pass over to Juka to provide us some further details on the development and validation of SteerSELECT as well as breed check. Thank you, Juka.
Okay, let's see if you can. Does it look okay?
Yes, all sorted.
Okay. So thank you very much for the opportunity, and I also want to thank everyone that connected and for the interest in our work. Christian mentioned that a key partner of the development of SteerSELECT was CSIRO, and CSIRO, I'm here representing a team of people, and the key brains behind this work is Tony Reverter, Pamela, Brett Hine, and Aaron, and myself. So we are a small team closely working with Angus Australia, and I want to mention here Christian and Malshani and the broader Angus team that contribute to develop and implementing this test. I'll repeat a few things from what Christian mentioned because I think it's a key component and very important, which is the mechanics about the SteerSELECT, Angus SteerSELECT is a genomic selection approach. And the key component is the reference population. So if you have, we need a reliable and very important, a very carefully developed reference population. And the reference population is a set of animals where you have trait records and also genomic profile. So with this combination of the trait records and the genomic profile, we can work the mathematics and then develop what we call the genomic prediction equation. But the genomic prediction equation is just as good as the reference population. So, and there are some important points to consider when you develop a reference population. One of them, I just highlighting some here. The size of the reference population, basically, the larger the reference population, the better will be the predictions. But also the reference population needs to represent the population that they will be testing. So if we want to test Angus cattle, we will need to develop a reference population of Angus cattle. We need accurate trait recording, so it's everything contributes to the quality of the reference population. But also we need a good, reliable, and proper density of the DNA marker. So the genomic profile has to be quite reliable and a good density of markers. And with all of these, we will need to go through lots of validation steps to make sure that this reference population is doing a proper job. So for these ones, we can somehow control, but there are some factors that are really developed or defined by the biology of the trait. So like how heritable the trait is, or the number of variants affecting these traits, and also how good is our genomic profile to capture those DNA variants. So those ones are a little bit trickier to control, but as you see, I hope you can demonstrate that we can work around the biological factors that we cannot control using developing a very good reference population. And then in the end, so how we're going to do? So we have a reference population, the prediction equation. When you have a test animal only with a genomic profile, we can refer to the genomic prediction equation and generate the breeding values. So this is this methodology is being developed for, I don't know, it's more than 20 years now, and is being proven for many different systems. And then here we are applying for the selection of animals going to feedlot. So I want to mention two articles that we developed. Two articles that derive from analysis that we did during the development of the Angus SteerSELECT. The first one here is called the phase 1 validation. So for this goes back a few years. We had a reference population of only 2,700 animals, and then the animals were feedlot finished, and then we had carcass records for carcass or carcass weight, marbling, and ossification for those animals. And these were very initial stages of the SteerSELECT. So we were keen to see if we could predict the performance of those 522 animals that we call the validation set. So the validation set are animals that we don't include in the reference population. So we will use just these 2,700 animals, trying to predict the performance of these 500 animals and see how we would do, how well we can do that. And in a somehow simplistic way, we develop a carcass value, which is a combination of the carcass weight and the marbling score of the animal. So we multiply by 5 and an extra $1 for each marbling score. So like if it's a carcass, if it's a marbling score 0 in a carcass, is the carcass value will be just the carcass weight by 5. And if you have a marbling score of 3, is the carcass value or carcass weight multiplied by 8. So this is just to have a feel of the dollar cents or dollar figure for the test. So before I show the plot, so I want to show similar to what Christian mentioned. So we do the prediction, and then we rank the animals by the prediction. And then in this case here, we split in 4 groups, in 4 quartiles. So the top 25% of the animals, the second 25, and so on until the bottom 25. So these are the top animals by the genetic test. And then this is the bottom animals by the genetic test. And then we go back to the real value of the trait, and then to evaluate how well the test performed. So the darker the blue here, the heavier the carcass. So that the top ones are the carcass weight. So that if the dark animals or the darker blue here are the heavier animals. So we would expect more of the heavy animals in the top quartile. If the test was 100% efficient, there will be all the black, all the dark animals will be here. Can you see this? Sorry. Give me something in my window, my screen. So you can see that we can see much darker blue in the top quartile compared to the fourth quartile. This works well for the short fat and the long fat, and similarly to the marbling score. So that we have much darker blue on the first quartile when we rank the animals with the test and observe the real phenotype. And when we multiply them, we do the calculation to do the carcass value. So we can see again much darker blue in the first quartile, which is the more valuable carcasses compared to the fourth quartile. And then if we put a table, this is as a dollar figure. So the first quartile here, the average carcass was 2,100 in the short fat, and the fourth quartile 1,700. So it's a $351 difference between the top and bottom quartile. and in the long fed is almost is double that figure, the dollar figure there. So remember, this is just with 2,700 animals in the reference population, and we were able to create to separate the animals in top and bottom quartiles that can capture the value of that. So it's a very encouraging result that this was like 2021 or 22 when we did this analysis, and it was very encouraging. And then I say, okay, with this, I think we are in the right track. So we should grow our reference population to do even a better job. And this is the next article that I want to talk about. I want to talk about this because we keen to increase the number of animals in our reference population so that we start considering using commercial data, cattle from commercial feedlots to add in the SteerSELECT reference population. And then the whole thing about this article is to evaluate if we should add if we could add the commercial cattle, commercial data into the reference population. And then I can tell you now is the commercial data, there are some trickeries that we need to work with to make it happen, but it significantly contributes to the genomic, to the prediction. And it's we could incorporate the commercial data into our SteerSELECT reference population only because our reference population does a good job for them. And then thinking about in the future, this will be the case. Some commercial cattle comparing to our reference population, and we're doing a good job. So we did a good job with before adding this commercial data. We can only do a better job with the next generation there. So for this article, we evaluated the genomic of the SteerSELECT. In this case, we have 3,700. So it's 1,000 more, is around 1,000 more than the previous study. So it's 3,700 animals in here in the reference population. And then we were investigating if we could add this 2,100 animals that we have from commercial feedlots that were genotyped. And again, I like this study because it demonstrates if it works well for these 2,000 animals here, it's very likely that will work for newer commercial cattle comparing to our feedlot, to our reference population. So this would work for other commercial cattle. So here are the two traits here only. So it's the carcass weight and marbling. So, and these are the 4 feedlots that we were exploring. See if we could do good predictions for those animals in the feedlot. And then here we have the bit of variation in the carcass weight. We can see the different feedlots, different average in the end, and the marbling score as well is quite variable there. And then another trickery that we had to do is like we have a different marbling score type, and but we can certainly accommodate that thing. Here is just to demonstrate here on the right side, the panel is the distribution of the carcass weight from the different feedlots. And you can see it's also in the table on the left there, the feedlot number 4. So we have a bit heavier animals compared to the other ones there. But remember that I mentioned about the reference population. The reference population needs to be relevant to the animals to be tested. And this is one of the first analysis that we do. So it's called the principal component analysis on the genetic relationship. So we calculate the genetic relationship using the genomic profile of the animals. And then in every dot or triangle here is an animal. And the black ones are the reference, the 3,700 animals. And the other 2,000 feedlot animals are the colored ones here. One thing that is very pleasing to see that is that our reference population and the commercial cattle from feedlot, directly from the feedlot, so they are very overlapping. So there's no grouping of the animals. So our reference population, original reference population with only the black dots, represents very well all the feedlot cattle from the 4 feedlots that we explore here. We know they are just high content Angus, but we didn't know how well they would be closely related. And then we can see that they are very much overlapping here. So there's no grouping. You'll see it later on what I mean about the grouping in here. The other analysis we had to do is see how the commercial cattle and our reference population, how the traits correlate. How the traits correlate to the carcass weight and the marbling. And then we can see they are highly correlated from the reference and the commercial cattle. So they have the same genetics. So the same genetic background and the heritability are also well within the reported estimates. So with these components, we can make very good predictions of the commercial cattle and also when they're together. And here are the accuracies. So here the first 3 bars refer to the carcass weight, and the second group of 3 bars are related to marbling. And these are, remember that also that I mentioned that we have to do lots of validation steps to make sure that this thing is working. So here I'm showing 3 of them. So we did 3 rounds of validation, and on the right here on the top, we see 1, we leave all commercial data out of the reference, and then we predict. And then in the validation 2, we leave 1 feedlot out, and we include the other 3 feedlots. And the feedlot in the validation 3, we leave 50% of the commercial cat out, and the other 50% we tested. So that we can see that we increasing the reference population with the commercial cattle, we increase the accuracy of genomic prediction. If we increase the accuracy of the genomic prediction, we demonstrated that it makes sense to add the commercial cattle in our prediction, because we will be able to better predict the phenotypes of the animals to be tested. So in this study, we demonstrated the genetic background of commercial cat with high Angus content is highly similar to the reference population. The genetics of the commercial traits and the reference are highly correlated, so we can do a good job to predict them. And we confirm that being part of the reference is beneficial. So if we add some of this commercial cattle in the reference population, we can do a better job to test the commercial cattle. So we were able to generate high accurate GEBVs for the commercial cattle using this reference population. With this study, we concluded that it's beneficial to bring this commercial cattle to our reference population, and this is what we did. So now the current reference population that we are working with, there is around 5,000 to 6,000 animals in the feedlot and carcass traits, which is the harder to measure traits. And then for yearly weight, we have many more animals, because it's just the availability of the animals. So we've started using this test with this population will certainly increase, and we're going to make even more reliable predictions. And at the moment, we're using a panel of 61,000 imputed SNPs genotype, a reference panel of 61,000 SNPs. And then what I think it's a nice thing that Angus Australia does is we can receive genotype, see the food zoetis or neogen, and they work around the imputation step so that any platform, both platforms can fit into the SteerSELECT. Just to finalize this part here of the SteerSELECT, I want you to highlight that this work there's a lot of rigorous scientific analysis on this that we're very proud of to put our work to test, and then we have a number of peer-reviewed publications that were developed during the development of this test, and we keep doing updates and putting to peer review for evaluation and improvement. At this time, just a brief pause, because I'm gonna change a little bit of gear, and I'm gonna talk a bit more about one of the components of the Angus SteerSELECT, which is the breed check. So the breed check is a genomic system to estimate the breed composition using genomic profiles. So the same genomic profile that comes from either companies go through the imputation pipeline in Angus Australia, and then we can use that genomic profile to compare with allele frequencies across different 11 breeds to estimate the breed composition. There is a strong focus on Angus content, which is the main component that we're trying to explore here. So this is another principal component analysis. But remember that our reference population is just a big cloud. That is because it's only Angus and high content Angus. So this is how it looks when you have multiple breeds. So different again, every dot or triangle is an animal, and the different colors are different breed populations. So here we have, for instance, the one on the left side, the Brahmans, and you have the Santa Gertrudes, the Wagyu group, the other taurine animals in here, and in this corner, Angus and Mara Grey, which are closely related. So this is our reference population for the breed check. Is a different type of reference population. These are different objectives. So it's a reference population to find breeds. So we need a variation here. And then this is how it looks when you do a principal component, when you have multiple breeds. And then we did lots of different validation steps for this test as well. Sorry, I got a lot of numbers here, but what I want to highlight here, we have the 11 breeds on the top. On the top, we have the 11 breeds that we estimating the content, okay? And on the left side here, we have the purebreds that we test against in our system. And let's focus on the diagonal, the red ones, the red blocks, the average percentage of the purebred that were attributed to that breed. So for like all the Angus animals, 99.91, all the animals had a 99.91 allocation to the Angus component of our test. And so on for the Brahma was like 99, and so on. So this is one of the validations that we did to demonstrate that our breed check is performing, doing the right things, okay? And like Christian said, so the reporting results we report as Angus and non-Angus. And also when is a non-Angus component is large, we're going to break into British, Indicus, European dairy, and Wagyu. I think this is the last one that I had. If you have questions, happy to give it a go.
Thank you, Juka. That was a great presentation on the technical side of SteerSELECT and breed check. So thank you very much. For all our attendees, we're now in our question and section. So if you have any questions, please feel free to pop them through in the question and answer box. Or if you would like to speak, feel free to just raise your hand and we can allow you to speak for your question as well. Question. I've got a question here that's come through around feedback from the supply chain, and that you gathered throughout the development phase, and what do you think, how do you think that SteerSELECT will be used?
Yeah, good question, Hanlie. Yeah, one of the really good things about this product is we actually started off developing this product in this on-prime course through CSIRO to help us really understand what the market required, and that was all based off trying to understand why there's variability at the carcass and consumer end. So some variability you can't explain, and genetics can help explain a big portion of that variability depending on the production system. So. And as part of that, we talked to lots of feedlots and brand owners and processors and so on, and that really revealed the need for this trait, but also the need for this product, but also where it might fit in the supply chain. So throughout all our discussions, it'll fit right along. So I think this will be used all the way from people breeding steers and backgrounding steers to feedlotting steers to processing steers and being the brand owner all the way back. So I can see it being used all along the supply chain. I know there is quite a few feed yards now thinking about how do we incentivise testing with SteerSELECT so we can get those steers tested early and have that information available for selection. They're also thinking about, not necessarily wanting to split up groups of steers from particular vendors. They want to keep that relationship and have those steers coming through, but maybe thinking about where they can go at their end. So can they have different supply chains? So the ones that do have propensity to marble, put those in the longer fed programs where that's required and is of value, compared to maybe some short fed programs or even grass fed programs if there may not be efficiency in the feed yard. So there's lots being talked about. Dare I say it, there was some discussions, and I won't put any feed yards names in it, but talk about, if this comes through in the future, could we build this in the payment grids for feeder steers as well? That's obviously a longer term discussion. Also, I thought an interesting angle too as well was from one of the marketing ends of one of the companies about if most of the steers are tested in their feed yard in the future, they can help understand what supply is coming through. So is this month going to be a bit lower for marbling because the genetics going in that month was a bit down, or is it going to be higher? So they can actually plan their marketing and selling of that product as well. So look, I think it's going to be used in a great range of ways, but it's going to be a time where we have to build the product out in the industry and I guess let the market decide how they best incorporating that, including the relationship between obviously the steer supplier and the processor, and that's something that I think will work itself through. Yep.
Thanks, Christian. And another question for you is, how does SteerSELECT relate to TACE EBVs? The SteerSELECT genetic predictions, how would they correlate back through to the size estimated breeding values?
Yeah, it's good. That's a really good question too. So they're two different models. So we do SteerSELECT is totally different to our TACE evaluation for our C stock animals or bull prediction particularly. What we do though is we look at the correlations between the two things. So even though the models are different, all the data, or essentially most of the data we use in SteerSELECT is in TACE as well. And even though the models are different, the relationships are really strong between the EBVs of the size and the steers. So if you wanted to improve, for example, any of the traits that we have TACE values for, like IMF, that relates to MSA marbling, you just select bulls with higher IMF, and that'll flow through to your SteerSELECT results. So the two things have crossover, that's for sure. Yeah. So you don't need to think about, I need SteerSELECT values on my bulls for selection. You don't need that. You can just use your TACE EBVs with confidence. Yep.
Sounds good. Thank you, Christian. And Juka, I've just got a question for you around the accuracies that you mentioned for the SteerSELECT genetic predictions. Could you please explain how these relate to the accuracies that are reflected on TACE EBVs, and just a bit of a comparison of the two different accuracies?
I think that what it might be as a surprise because maybe it's a bit too high accuracies. There are different ways to calculate the accuracy. This is one is it's called the traditional way, and then and another one is called the method LR. So different ways to reflect the accuracy. So maybe this person is a bit inquiring about the differences because it's the method LR seems to have a bit higher number, or I want to say like 50% in method LR quite often in a traditional will be around 40 instead of 50, something like that. So it's just a different scale. It's just a different scale.
Do you have anything you want to add to that, Christian, before we move on to Adam's presentation?
Oh no, it's a sort of it nearly needs to be in my thoughts. You nearly need to look at them differently. So what Juka presented wasn't EBV accuracy like we're used to seeing in our C stock animals. It was like prediction accuracy. How well does those genotypes predict the phenotypes in that sense? So it does use a method called LR, which is well published if anyone wants to find out about it. So it's just a scientific way of looking of doing some validation, I guess you would say, and understanding the relationship between predictions and phenotypes.
Sounds good. Well, thank you everyone for your questions. We'll just jump through to Adam's presentation on how the details on ordering SteerSELECT and covering through on the timeframes and everything that's associated with that. Thank you, Adam.
Thanks, Hanlie. Hi, everyone, and thanks for joining the webinar. So I'm just going to step through the ordering process and just some things to be mindful of when ordering SteerSELECT through Angus Australia. So the SteerSELECT is available direct through Angus Australia and also both our collaborators, Zoetis and Neogen. So for more information on how they would do their ordering process, which will essentially be the same, I would definitely reach out to your local rep, whether that's Zoetis or Neogen, or contact the labs directly and get in touch. Or if you do need any information, we can point you in the right direction if you want to contact the member services team here at Angus Australia. So for anybody that's actually done heifer select before, the process will be very similar, but basically the same. But I'll touch through a few more points on that later on down the track. So the cost of the product per test is $39.50. So each animal, each sample will be a $39.50 charge for the test to be done. The turnaround times are, we generally allow 6 to 8 weeks for results to come back in. They can come in quicker than that, but we generally just give that 6 to 8 week turnaround time just so people give yourself time to get the samples in if you're waiting on the results, or it's a time sensitive matter. You also need to be a current financial member of Angus Australia. So if you're not a member already, an annual fee for $110 will cover your membership, and you'll also need to have the genetic evaluation services added to your account as well. So that's an additional cost of $165 annually. DNA samples can be submitted either by tail hair samples or TSUs. So if you haven't done it in the past, what you'll need to do is take a good notch of hair from the tail from the animal and supply it on a hair collector card. We do supply these through Angus Australia, and so do Zoetis and Neogen. So if you need the collector cards or you haven't got some on hand, reach out and we can get them sent out, we'll post them out to you and charge it to your account. Same with the TSUs and the TSU guns. So we also can supply those if you don't have them. But one thing to be mindful of when taking the TSU samples is to make sure when you've taken the sample, you've got a tight seal on the TSUs and that there is a good notch of tissue in the vial. So you just want to be making sure that you're not sending a sample that's potentially not being able to be tested because you missed that tissue sample. So the SteerSELECT test can be ordered for straight bred Angus, and we do recommend that you're testing animals that are a greater content of 87.5% Angus content, so 7/8 Angus content. They cannot be ordered for animals that have been registered on the database previously. So animals that have been recorded in the HBR, APR, ACR, or MBR registers, you cannot order SteerSELECT for. So just be mindful of that. So sire verification can also be requested with SteerSELECT. So if you do know that the sires have been registered with Angus Australia, just make sure to check that they have a genomic profile recorded against them, and we can run that parent verification when we get the results back in here at Angus Australia. Most sires will already have a profile recorded, but if not, and you do own the sires, you can submit a DNA sample for testing, so we can get a genomic profile on that sire and then parent verify to the animals you put through SteerSELECT. Pesty testing is an additional add-on that we can send away with your SteerSELECT as well, and that's an additional $9.90 per test. So I'll run through the order forms in a moment, but yeah, you can add those on for each individual animal if need be, or the whole lot. But it's mindful to note that Zoetis will only accept TSU samples to do the pesty testing, and Neogen will either do the TSU or the hair sample. So just be mindful of that when ordering your SteerSELECT. So once you've collected the samples and you've filled out the order forms, we do require the Excel version to be emailed back to us here at Angus Australia, to dna@angusaustralia.com.au, and also print and enclose a copy of your order forms with the TSU samples that you are posting to us or to Zoetis or Neogen. I'll also suggest that if you are posting TSU samples, try to put them in a Ziploc bag when posting, because we have in the past received packages that have been torn in transit, and TSU samples have been missing at this end. So yeah, try to keep them together as best you can before posting them to either one of us. So the order forms here, so you want to just make sure that you've got your membership ID, which is your 3-letter herd ID, and the membership name that the account is actually under. So whoever's name is on the account, we need that in that membership name. And then select whichever test you're doing. So if you're just doing the straight SteerSELECT, tick the first box, or if you do want that pesty added on, you need to tick that second box as well. The number of animals that you are testing, and whatever price, so whether it be that straight SteerSELECT to be $39.50 or the $48.40 for the Angus plus the SteerSELECT plus the pesty, and that price will generate on its own accord. And also the bottom of this page, make sure you sign and date it. So it basically gives us the approval that you are putting this through, and you're happy for us to go ahead with the testing. So this is what the order form essentially looks like. You want to make sure you've got all that information in there, so there's no sample mix-ups, and we are actually allocating the samples to the correct animals. So the sample type, whether it's a TSU or a hair sample, the sample barcode, really important, member ID, birth year, the tag number of the animal, the RFID, the sex of the animal, and is it 100% Angus, yes or no, basically in that column. This is also where you would put in for the size that you want to nominate to parent verify to the animals that you are testing. So you've got eight slots there, but if you do need more, if you've got groups of size that you do want to test, the following page within that Excel has another 10 columns that you can group size in that you would like to test. So other than that, I've pretty much covered everything I need to. All of these forms are available on the Angus Australia website. So if you navigate to Australia, AngusAustralia.com.au, the bottom of the page, there is a tab, Member Forms, and everything you need can be found in there. If you do need help finding anything, or you have any questions, please reach out to the Member Services team, and someone will be able to navigate you through whatever you need to find, or if you just need some forms sent directly to you, we can also work on that as well. So that's pretty much it for me, Hanlie. Thanks.
Thank you, Adam. And just in lieu of time, I'll just quickly jump through my section on how to access the results. So the results will be available in Angus Tech under AngusSELECT. Just find SteerSELECT there. And then from there, you're able to do selection criteria against the search function based on the animal's details, the genetic predictions, moving those slider bars or entering your minimum and maximum levels, as well as whether the results are available whether the animal has registered to an Angus Australia registered sire, and whether the animal has come back as 87.5% Angus content or greater. So this is a snapshot of what the results will look like in the reporting centre. You'll notice there that you can see the animal's ident, their birth year, their sire ID for animals that have verified to a sire, as well as the breed check tick and cross for those that are 87.5% content or greater will get a tick, and those that are below a cross, and then those 9 genetic predictions and the Angus sire value, steer value, sorry. From there, you can also drill down a little bit deeper into each of those animals. So on the left-hand side, there'll be a little arrow that you can click and it'll populate these sections underneath an animal. You can drill into their breed check results a little bit further there, as well as looking at that genetic prediction chart. Another really great function of Angus SteerSELECT is in the reporting centre. You're able to drill into your results a little bit easier with the Analyze results section, as well as download a PDF or a CSV so that you can analyse the results in Excel if you wish. So just a little bit on where you can find some resources. So we've got our Angus Education Centre module, and I will send through links post this webinar to each of these locations, as well as where you can download the order forms that Adam was mentioning earlier as well. So we also have developed a general brochure that goes through the product overview, and then a more technical bulletin as well. If you do have any questions about the ordering process or becoming a member, our member services department will be able to help you out there. If you have any questions more on how to look at your results or how does SteerSELECT suit my operation and my supply chain, please feel free to contact myself or Christian, and we'd be more than happy to help you through there. Neogen and Zoetis, our genetic collaborators, are great resources of information as well, and they are all across Angus SteerSELECT as well, so feel free to reach out to them as well. And for any more technical questions, we're happy to put people in contact with CSIRO as well, and liaise with them. So thank you everyone for your time today. If you have any further questions, please feel free to contact myself or Adam or Christian, and Juka as well. I just want to thank Juka Poneto from CSIRO for his contribution today, and thank the wider CSIRO team for their contributions in the development and validation of Angus SteerSELECT. And I also want to thank my colleagues Christian and Adam for their willingness to present to you all today as well, and the wider Angus Australia team for their hard work in the getting SteerSELECT up and bringing it to the market. So thank you everyone, and thank you to all of those who have attended. I will send through a follow-up email with all those links and everything for you. I hope everyone has a lovely day.